Hello and welcome to a new video. In today's video, we discuss some potential alternatives for the established power tool housing materials. Okay, let us get started. So the established materials for power tools are mainly polyamides, in particular polyamide 6 with 30 weight per cent glass fiber and also with impact modifications. And those materials are since I would say over 20-25 years established, and also the polyamide over the time get better, the formulations and the compounding, so the quality of the parts improved over the time. However, in parallel we see some uprising potential replacement materials. For example, ABS is coming more and more for certain parts of power tools. However, also polypropylene. And this is what we will dive now more deeper. In particular, relevant to replace a polyamide 6 GF30 are polypropylenes which have chemically coupled glass fibers. And what you can see here now on my side is the tensile strength in megapascals of a polypropylene with standard glass fiber reinforcement, and then a polypropylene with chemically coupled glass fibers. And it is always 30 weight per cent glass fiber loading. And then on the right in orange, we have a polyamide 6 with 30 weight per cent glass fibers in comparison. And what we can see here, that with the chemically coupled glass fiber PP compounds, where I put the red box around, you can see improvement in the tensile strength from around 180 to 190% compared to the unreinforced polypropylene, and double compared to the standard glass fiber reinforced polypropylene. And now, interesting is when we compare it to the polyamide 6 in the conditioned state. So there we have always around 100, 110 megapascal for polyamide 6 GF30, and we reach already such a level. So we are slightly still below, but we reach already such a performance level, which is really interesting for designing also such engineering parts. Okay, apart from the tensile strength, let us have a look now at some other properties and advantages of polypropylene with chemically coupled glass fibers. So on the one hand, we have excellent flow of such polypropylenes, so we can have longer flow length and we can fill also more complicated geometries. Then we have good impact properties, and important is that we are not losing these impact properties in the minus temperature range, and we have almost the same deformation capability as a polyamide. So then important point is the lower pricing, the lower cost of the material, and we have also good heat distortion temperatures, not as high as with polyamides. However, for certain engineering applications, this is enough. Then we have a low density, and there is no need of conditioning compared also to polyamide, where we have also the dry state and also the conditioned state. Looking at some critical topics, so with such polypropylenes, we have a higher shrinkage warpage level compared to polyamides. That means we have a more stronger dependency of the shrinkage in the flow direction, and we have also a higher dependency to take up the stresses in the flow direction compared to a polyamide. Then also important topic is surface quality, especially with power tools, where we always have a look. So here we cannot match yet this surface quality. However, for certain other applications, this is already the case. And important in terms of processing, polypropylenes have a bit longer processing cycle, so around 10 to 15% compared to a polyamide. And in the part design phase, this is important, there is more engineering and more know-how needed to make such parts. however, all over, replacing engineering plastics by some cheaper commodity plastics such as this polypropylene with chemically coupled glass fiber is in full swing. And important is for the part design engineers to balance integration of function and have high part quality, because we have a reduced level of mechanical properties with such materials. So it's really, here is more know-how needed, and also more systematic approach in the selection of the particular polypropylene grades. Okay, that was our comparison, polyamide 6 versus the polypropylene for power tools. Hope you enjoyed the video, and thank you again for watching, and see you in the next one. Bye.